In this video, you are going to understand how to evaluate a definite integral. Okay. Now, for that, very first thing what you need to understand is that if you look at the formula, we have integral f of x dx from a to b is equal to, see, we have f of x, correct? That's all. Now, what I'm trying to tell you is there is no plus c, there is no integration constant at all. Why we don't have integration constant? That is the next part. Okay, and this formula what you're seeing is not the complete formula. Fine, what exactly happens, we are going to discuss about it now. See, when you integrate, especially a definite integral, the resulting value whatever you have is a function, correct? Like if you integrate x square, you know the result is going to be a function, that is x cubed divided by 3. So integration of a function is going to give you a function. Whereas in definite integral, don't you think that we are trying to calculate the area under the curve? So area cannot be a function. Area has to be a value, isn't it? Now, this is where the limits of the integration are important. Okay, now you are going to understand this is the new part, that is limit of the integration. So there are two limits, upper limit and lower limit. So here a is what we call as the lower limit. This is the lower limit. And then b, this is called as the upper limit. All right, so we have lower limit and upper limit. Now, once you integrate the resulting function, what you get, you apply the value of upper limit, you apply the value of the lower limit. In the sense, here you have integration of f of x is nothing but capital F of x, right? Now take plus c. This is the indefinite integral, whatever we have studied. Now you have from a to b. First, what we do is we are going to take the value of b and put it in the function. Okay, that means here f of b plus c, correct? Then what about the a value? That also we need to calculate. Now, since it is the lower limit, we subtract the lower limit from the upper limit. There is a reason behind it. If you remember in the last video when we discussed this fundamental theorem of calculus, you had a graph. This is A, this is B. Now, when you calculate f of B, capital F of B, that is going to give us the area from this point all the way till here, like everything, the whole area. But when you do f of A from this point to this point, so this area is gone. In the sense, you are doing the total area. So here, you're doing the total area minus this particular part. Don't you think that is going to give us the required area? I don't have to calculate anything which is additional. I mean, that makes no sense, right? Now, what we are trying to do, we are trying to calculate the required area. If you do f of b, then that's going to give us from point B all the way till wherever it is 0, isn't it? The whole thing it's going to give. That is not required. So what do? To counteract that extra whatever we are getting, we subtract f of a. That means here you have f of b plus c minus of f of a plus c. Understood, right? So f of b gives us the area from that point all the way till origin, like the whole thing. F of a also does the same thing, but f of a starts from point A, right? So in between that region, between A and B, that is what is required for us. So you do f of b minus f of a. So the value, finally, integral value is going to be integral of a to b f of x dx is equal to f of b minus f of a. The c and c gets cancelled, right? So the final value is basically this. Clear? So this is the formula what we are going to use to evaluate a definite integral. Now let me show you an example. Okay, let me show you an example so that you can understand it much easier. All right. See this one. Say you have integral of, say, x cube minus 1, say from 0 to, say, 1. Simple example we'll take. Or maybe 0 to 2. I think there you will understand that how it works. Now, very first thing what you have to do, split the integral, right? Integral x cube minus, right? This is the value. This is the integration part. Now, x cube you have to integrate, which is x power 4 divided by 4. So, you have this as first part minus x. Now, there's no plus c. The next what you're doing is you have to substitute the limit. There are multiple ways of writing, okay? You can put it in square bracket, one side bracket, or a line. Any of these things you can use. I mean, basically all are one and the same, just a different notation. Now here you can write it like this, right? So you can write it like this, or you can just write one line. That's also good enough. So here we are going to just write one line. This is 0 to 2. 0 to 2. That means where you have to take 2, which is the upper limit, substitute in the variable. Then you have to take the lower limit, substitute in the variable, subtract these two values. That is, take 2, get a value, put 0, get a value, subtract both of them. Understood? So that means here when you apply the value, you have 1 by 4 of 2 to the power of 4, the first value, right? 2 to the power of 4 minus 0 to the power of 4. Correct? Now what do we have? Oh, minus of 2 minus 0. In place of x, you have to write 2. In place of x, you have to write 0. Now, this is going to be 1 by 4 of 16. 0 power 4, anyway. Minus 2, right? So, the final answer, what you have is 2. Correct? The final answer is going to be 2. So, this is the answer for the given question. So, no function, no plus c, nothing doing, only a numerical value. Once you have the numerical value, you can figure it out. Oh yeah, this is how we do it. So it is just plain old integration, whatever you have learned. The only difference is you need to take the upper limit, put it, take the lower limit, put it, and get the things done. Clear? So this is what we have in this video. And in the next video, we will start with problems based on whatever the definite integral we have done.